If there is no electricity in the world, we will spend every night in darkness. If there is no electricity in the world, all the machines in factories will stop production. If there is no electricity in the world, all electrical appliances will not exist. How inconvenient it will be for our lives. In fact, in industry, agriculture, and daily life, the most widely used is alternating current, even in some places that require direct current. It is also converted into direct current. Why is alternating current so widely used? What is alternating current? What are the three elements of a sine alternating current? Now let's start learning about our task. Before we start learning, please observe the figure. What is the difference between direct current and alternating current? First, let's learn the basic concepts of AC circuits. Let's learn the basic concepts of AC circuits. The magnitude and direction, voltage or current, that changes with time is called alternating current. There are many kinds of changing waveforms, such as an isosceles triangle wave, rectangular pulse wave, and sine wave, etc. Among them, the magnitude and direction vary with time. That changes according to the sine law. Is called sinusoidal alternating current. Sine alternating current is widely used in industrial and agricultural production, scientific research and daily life. The difference between direct current and alternating current. Let's learn the difference between direct current and AC. Returning to the previous picture, we can know that there are the following differences between them. First, the magnitude of direct current will not change, while the magnitude of AC current changes with the cycle. Second, the direction of direct current is always from positive to negative, will not change, while the direction of AC current will change repeatedly with the cycle. Third, AC is suitable for power circuit transmission, transformers and so on, while direct current is suitable for electronic instruments. Aspects. Third, the period, frequency, and angular frequency of sinusoidal AC. One is the time it takes for a sinusoidal quantity to change, is called the period, denoted by T. Second, the number of cycles experienced by a sinusoidal quantity in 1 second, is called frequency, denoted by F. Third, the number of radians a sinusoidal quantity experiences in 1 second, is called angular frequency, and is represented by omega. These three are from different perspectives, reflect the same problem. The rate of change of the sinusoidal quantity with time. Fourth, instantaneous. The maximum and effective values. First, instantaneous value. The sinusoidal quantity changes with time, according to the sine law. The value corresponding to each moment is called the instantaneous value. The instantaneous value is a variable. Note that lowercase English letters should be used. The corresponding expression of the positive direction is a trigonometric function, analytical expression, I equals lmsin, omega t plus phi 0. The maximum value. The highest point of the sinusoidal oscillation is called the maximum value. It is represented by or im. 3. Effective value. The effective value refers to the DC value that is the same as the sinusoidal calorimetric effect. Effective value can accurately reflect the magnitude of the sine, AC. Fifth, the phase, initial phase, and phase difference of sinusoidal AC. Phase is an electrical angle that varies with time. It is a function of time t. In the equation, I equals imsin omega t plus phi 0. T plus phi 0 represents the phase f, phi ling represents the initial phase. 2. Initial phase. The initial phase is the exact electrical angle at t equals 0. The initial phase determines the starting position of the sinusoidal quantity. The initial phase shall not exceed plus or minus 180 degrees. The phase difference between two sinusoidal quantity of the same frequency is actually equal to the difference in their initial phases. Note: there is no concept of phase difference between sinusoidal quantities with different frequency. The phase difference shall not exceed plus or minus 180 degrees. The intersection of the sinusoidal quantity and the vertical axis is at the positive half cycle. The initial phase is positive. If the intersection with the vertical axis is in the negative half cycle, the initial phase is negative. The three elements of sinusoidal alternating current. We know that sin alternating current has the following three elements. 1. The maximum value of the sinusoidal quantity. 2nd, angular frequency. 3rd, initial phase. The maximum value reflects the magnitude and work capability of the sinusoidal quantity. The angular frequency reflects the speed of the sinusoidal quantity change over time. The initial phase determines the starting position of the sinusoidal quantity. Through the above courses, sinusoidal alternating current of have a preliminary understanding? We need to learn to distinguish alternating current from direct current. Master the three elements of sinusoidal AC, and through formulas and waveform diagrams, to obtain the maximum value, the concept and value of initial phase and angular frequency. That's all for this lesson. We need to review more after class. To master the content of this lesson, please calculate the phase difference of the phase difference of U equals 5 sine omega t plus 15 degrees volt and I equals 5 sine to omega t plus 15 degrees ampere.